Okay, so good afternoon everyone. So for today's lesson, we focus on the two experiment we are designed. Okay, so here is regarding the simple pendulum, as most of you request. Okay, so the first is related to study the relationship between the length of pendulum with oscillation period. Okay, this is the first. So for today's lesson, we are going to discuss two experiment. Okay, so first is the relationship between the length of the pendulum using symbol LR, and then another one is the oscillation period using T. Okay, so another experiment related to simple pendulum will be to determine the gravitational acceleration of Earth will be G. Right, I think all of you quite clear already. So this is the syllabus for Form 1. You can go through the textbook, section 1.2. We have one simple pendulum experiment. Discuss about how to determine the gravitational acceleration. Okay, so basically you need to know the type of experiment going to test. Okay, so you can classify to two actually. I think all of you should be very clear already. So it's first one, hypothesis experiment, normally involving the 5 manipulated variable and responding variable, and then ask you to plot the graph. Okay, then the second one is a non-hypothesis experiment, just like ask you to get the critical angle, example, by using the semicircle lens, right? Okay, so it's one of the example. Okay, so for sure for this discussion today, simple pendulum is classified as the hypothesis experiment. So two of the experiment, first and second, will be hypothesis involving the MV and RV. Okay, then another type is type of question you are going to know. So if let's say your question is guided or tugasan Amali Berpandu, the procedure will be provided. So it's very easy, just follow, right? But if I say the procedure is not given, it's known as the non-guided practical assessment or tugasan Amali Tidak Berpandu. So you need to write the procedure. Okay, so how to write the procedure? Later on we'll discuss. Okay, so the first experiment will be related to tugasan Amali Tidak Berpandu. The second one, determine the G. We use the example of guided practical assignment. Okay, so you can see the first, as mentioned, we are going to discuss the relationship between length of pendulum with oscillation period. Okay, so the type of experiment will be hypothesis. So the MV and RV you need to give 5 for minimum. Then another one will be the non-guided. The type of question we're going to discuss. So the first question will be the non-guided one, Amali Tidak Berpandu. Okay, so I continue with the checklist. Okay, so I think all of you should know already. You'll get a checklist, right? So here the apparatus involved will be pendulum, bob, meter rule, stopwatch, record stand, reclamp, RCM thread, protector, cord, nail, and weight. Okay, so the pendulum bob, normally they have a specific mass. For example, we're using 250 grams example. Okay, so here you're allowed to read the question and check the apparatus within 5 minutes. Okay, after that you'll start your experiment. So that means that the total period provided is 45 minutes. Minus 5 minutes, you left only 40 minutes. So you must have a very good time management. Or you not only do the experiment, the most important is the question you need to finish. You use 35 minutes to conduct very good experiment, 5 minutes to complete your test paper is impossible. So I think the maximum time will be 20 minutes for your experiment. After that, you have to answer your question already. Okay? So normally no problem one, you just tick. Okay? Okay, then you have to go for the question. The question will be this now, the first question. You are required to carry out experiment to study the relationship between the length of pendulum. Normally, they will give you with symbol. You just follow the symbol. Okay, and the oscillation period, here we using symbol T. Okay, so here, procedure. Okay, so plan your experiment using the apparatus and material provided. So your procedure should be including method to handle variable. Precaution, 5 marks. Okay, so the first you should identify the MV and RV in your M. Normally they will give you the M. So this is the M to study the relationship between the length and the period, right? So you identify your MV and RV first, so then you can conduct experiment, right? Okay. And then second, you see the marks, 5 marks here. So you need to know how's the distribution of marks. So here the 4 marks show will be method to handle in your procedure. Then 1 mark will be at your precaution. If I say the question come up is Amali Tidak Berpandu. So it will be normally like this. Okay, so for the answering technique for procedure, for any type of experiment will be like this. First, you have to draw correct diagram and label the diagram. So this is the first. Okay, second, you have to give your first MV and first RV. So the first MV very clear will be the length of pendulum. Okay, so here you can plan your own. Since here this question is Amali Tidak Berpandu, so you can give any length which is reasonable. Okay, so just now we have a track with 100 cm, so you have to plan 5 data. So for this experiment, I plan 20, 30, 40, 50, and 60 lah. Okay, so the most important thing is the sensitivity of the apparatus you use. So here, 20 cm will be wrong because the ruler, the smallest division of sensitivity is 0.1 cm. If you give 20 wrong, you have to give 20.0 cm. Depends on your ruler sensitivity lah. Should be 0.0 lah. Okay, then the RV will be the time taken for 10 oscillation. Or you can make it 20 oscillation also, doesn't matter. Okay, but remember the one complete oscillation is from A to B and then return back to A, not A to B only. A to B, return to A is actually one complete oscillation. And the T here referring to one oscillation. So that means that if you're using 10 oscillation, your T should be divided 10. If you're using 20 oscillation, then you have to divide 20. Okay? This is what I mentioned just now. Okay, then the last mark will be repeating the MV and RV at least 4 times because we have to get minimum 5 MV and 5 RV. I think this one you should be clear already. Okay, so for this experiment, I think it's very easy to give the procedure. Okay, so the answer should be diagram 1 mark, procedure 3 marks, and precaution 1 mark. Okay, so here, firstly, you have to draw your diagram. You see, the apparatus as shown in figure above is set up. Or you have to draw, label everything. Label everything, so you get the first mark. M1 is the first mark with diagram. Okay, so as mentioned, suppose you give the passive sentence, but so far active, the marker still accepted. Actually, you need to give a passive sentence. Okay, then second, you see here, give first MV and first RV. So the sentence will be this: length of pendulum with L 20.0 cm is adjusted. The pendulum is displays the side at the angle of less than 10. Okay, so the angle should be less than 10 actually. From the vertical and release it. So the time taken for 10 oscillation is recorded. So you can see here I mentioned already the first MV. Sensitivity 0.0. You must give. Okay, and then here time taken for 10 oscillation. So this is the first RV. Okay, so actually, I put the precaution inside already. Why we want to using less than 10? Because we want to reduce the impact of amplitude. So that the result will be more accurate. This will be precaution you should you can add on actually. Okay, so here you see the hot tips here is given correct sensitivity of reading for length and the time taken. Okay, so you can see here I give you an example of the stopwatch already. You see, for stopwatch, every segment actually we have very small one. So 1, 2, 3, 4, 5, right? The 160 to 1 actually got 10 segments. So 1 divide 10 is actually 0.1. Also, the paper 3 actually we focus on the sensitivity of the apparatus. So must give the smallest division for ruler 0.1. So that means that 1 decimal place. then the stopwatch for your result in tabulation should be also 1 decimal place. Okay. Okay, then here the last will be repeating the step 2 with the another 4 appropriate value, or MV here will be 30, 40, 50, and 60 again must be together with 0.0 or represent the sensitivity of rule we use now. Okay, then here you need to add on also the period oscillation actually we want to get is only 1. Why we want to using 10 or more oscillation? Because we want to increase the accuracy. Because the reaction time will be better to control with more oscillation. Okay, because one oscillation is very hard for us to straight away stop the stopwatch. So if you give more time of the oscillation, actually accuracy of the reaction time will be increased. Okay, so now I continue with the next question. Okay, so here, okay, so another mark is for precaution. Okay, so the precaution, they will be strictly need students to give the method plus reason. You must give this format. Okay, what means by this? Okay, so I give one example. Okay, so here, keep the amplitude of swing less than 10 degrees from the vertical to ensure that the period of oscillation is independent of amplitude, because the amplitude will be affecting the value of G. Okay, so here, where is the method? Keep amplitude less than 10 from vertical. This will be actually method. Then to ensure that the period of oscillation is independent of amplitude. So this will be the reason. Okay, so why you can see here, our G is not dependent of the degree or angle, right? Okay, so that how we can make the T independence to amplitude or swing angle. So you must make sure that less than 10. Actually, if you go to search Google, less than 5, or the smallest the angle you replace, they will be more accurate. Okay. Okay. So here, if let's say you go through more detail, the first sentence I think you understand now. Also, a pendulum swing through a large angle is being pulled down by gravity for a longer part of its swing than the smaller angle. So conclusion here, just want to tell you that. So the angle should be replaced less than 10. So that here, the motion will be known as simple harmonic. This one actually is from 6 higher level one. So here just want to tell you that if you give less than 10, you will meet simple harmonic motion already. Okay? Okay, so here this is the first precaution for reference. Another one is very easy one. Okay, this one is the second one. The position of the eye is perpendicular to the scale reading. This is can be applied for all experiment, right? When you use the ruler, when you look at the time stopwatch here, right? So your eyes must be perpendicular to the scale reading so that you can avoid Barrett's error. This is a very easy answer. You can use the second one, right? This is the method and this is the reason. So as long as you meet the format precaution where we're using method plus reason, the marks will be given. Okay, so this is the answering technique for the precaution. Everyone, I think you also not very hard, right? You can just give the second method. Okay. Okay, so after that you have to start your experiment already now. So for just now I advise that you have to complete within 20 minutes. Okay, so here, okay, so the key point here is the sensitivity of the stopwatch will be 1 decimal place only. Okay, so here is just a reference result. Okay, so where I get from books actually. So this is 5 theta is the minimum. Okay, so how many times you have to do? Actually, you do 1 time enough already. No need to do 2 times and then divide 2. No need. You go through 1 time first. The result can use you straight away plot the graph. Okay. Okay, so here the second question here is the tabulation. Okay, so tabulate your data for LT, capital T and T square in the space below. So here, so this is result we get. Okay, so here I think I can mess it again. 0.0. Here all must 0.0. Okay, so this is a reference data lah, but by using 20 to 60. Okay, so the trend must be, you see the T must be increases. The longer the pendulum, the T you get must be longer lah, the time taken. You get shorter, that means something went wrong already. Okay? Okay, so here the tips will be the first, you must label all the symbol. Oh, so here give you all the symbol, you just use it. Cannot use others. Second, make sure you give correct unit for all. Then third, must give consistent decimal place. Okay, so the data we get for measurement, we know as primary reading. Consistent means what? You see, here, if I say your first data you get 8.9 is with 1 decimal place, right? The second you get 11. You cannot give 11 without decimal place. You must give 11.0 so that your decimal place is consistent. If you give 11, 1 tick deduct already. Okay, so make sure the decimal place is consistent. If you give 2, all will be 2. Okay, as mentioned to you. So if I say you're using ruler, you want to give 2 decimal places, 2 decimal places, that means the second place must be 0 or 5 only. Impossible others, because segment with segment, here we accept 0 or 5. But actually you don't need that. If you get half like this at the middle, you can take front or behind numbers. Because when you go for plotting the graph, actually we don't use so many decimal places. Okay? Okay, then. Okay, so for calculation, okay, so this is, when calculation, this is considered as a secondary reading. Okay, so for secondary reading, you can give 2, 3, or 4, up to you. Okay, again, you don't need to give too many because the graph, you don't need to have so accurate decimal places, right? So you will be route off of the later on. So if you give 2, or you have to give 2. Okay. So I think I advise 2 also lah. Okay, then here, again, if 1.10 you give 1.1 is considered not consistent. Okay, then T square, here we have 4 decimal places. I also leave it with 2. When 2, all must be 2, is it? Right? Okay? Okay, so that means that for the tabulation, first, you must give quantity physics to be this. Second, unit. Then third, okay, so here got 2 tick. That means that they want to look at the sensitivity of the apparatus, but consistent. So that means that must 0.0. Without 0.0, 1 tick will be lost. Okay, and then the consistency, that means the decimal place must be always the same. Okay, then the secondary reading must be have consistent decimal places also, as I mentioned. If you give 2, all must be 2. If you give 3, all must be 3. Or, okay, I think this one is not very hard. If you get all the tick here, 6 tick, correct, then you can get full marks. Last one will be deduct marks. They have a range. Okay, then here, see we go for plotting the graph. Okay, so the graph for experiment 1 and 2, I do some changes. So the experiment 1, actually I exactly follow the books. The graph asked to plot is T square against L. Or T square is against L. Okay, so that means that T square is Y axis, L will be X axis. Okay, so this is what the data we want to use. Or just now I transfer from the question B just now. Okay. Okay, so answering technique for plotting the graph here, you have 7 tick need to fulfill, or 7 tick. First, you must give correct quantity physics for each axis. So here you see, T square will be the symbol, or the quantity physics you must give for axis S and Y. Here T square and L actually. Second tick will be unit for each axis. So here will be second square, here will be cm for x axis. So second must be give correct unit. Then third tick will be the skew. Skew uniform. What means by uniform? You see, you must covering the minimum value and maximum value. So the minimum value will be 0.79 and 20. 2.4 and 60.0 be the maximum. Your skill must be including all the value here. And then the advice skill will be 1 unit represent 1, 2, 5 or 10. Okay, it's the best skill. Okay, so as mentioned just down here, we have a maximum and minimum value you need to cover in your skill. Okay, and then so with this now, you see up to I give up to 4, actually until 2.5, 2.4, right? Okay, and then here 60. Okay, so for this, the x-axis and y-axis, you just divide 10, so that you know the smallest one is how many? 0.05. And here is 1, right? Okay, then the size of the graph must be 4 times 5. 4, that means here 4 unit with 5 unit. This is a minimum. That means the minimum will be the half of the graph. Or 5 with 4 minimum lah. The bigger the size you draw, the more accurate of the gradients you will get lah. Okay. Okay, then the next will be to tick for plotting all point correctly. Okay, so if you get this one 0.05, that means that you can use your y-axis value 0.79. I write up to 0.80. Actually, you can use 0.79 divide 0.05. So you know how many blocks you are going to plot already. Okay. Okay. So if let's say we look at 0.79, divide 0.79 divide 0.05, we need 15.8 box, small box I mean. So that means that nearly 16, right? So you plot here. So this is how you get why you want to get the smaller division for your each axis here. Okay, so the others plot you just follow like this. Okay, then you can get the tick number 6 already. The last will be the baseline. Okay, so for baseline, 2 requirements here. Okay, so the numbers of point different above and below must be 0 or 1. So what? Okay, so if you look at here consider this point is at bottom, right? Then no any point is on the top. So 1 minus 0, 1 still accepted. Okay, so this is the baseline. Second is the point to the line must be less than 0.5. So that means that first, if I say our plot all the point is not on the line like this one still meet the baseline because here 3 on the top, 2 at bottom. 3 minus 2 is 1, right? If the distance between the point to the line is less than 0.1, this is still a baseline, although all the point is not in the line. Okay? Okay, so here 7 tick you can get full marks, 3 marks here. Okay, so you can practice your own later on this one. Then the next here. Okay, so now based on the graph at B, at C actually is at C. Okay, so state the relationship between T squared against L. I think this one is very easy, right? Okay, see, if passing through origin, you must give directly proportional. Okay, so if you get the graph like this, not touch your origin, you should give increases linearly. But you have to think, for this experiment, the formula we use is T equal to 2 pi square root L over G. Then when we rearrange to become T squared over L, actually no any C, right? Suppose your graph should be pass through origin. Okay. However, if you really get this, you just give increases linearly. So I think others part you might get deduction already. So when you think type of graph, you have to think the theory. Okay, so the gradients actually will be this, right? 4 pi square over G will be the gradients actually. Okay, so but here very clear the answer will be Y is directly proportional to X. So T square directly proportional to L. This one you should get this . Okay, it's no any problem actually because the first experiment very easy. Okay, then the next. Okay, so here, so the question here, predict the changes in gradients of the graph if this experiment was carried out on the surface of moon. Explain in 2 marks. Okay, so gradient suppose, crater. Okay, so here we have crater. Okay, so how we know? Again, you go back to formula, you see, t square equal to 4 pi square over GL, right? This one is come from the formula just now I showed you, right? T equal to okay, so from here, you must change to y equal to ms plus c. But the c here is 0 now. So our y is t square. So we square both sides, here square and here square. You rearrange, you get this. So here our y is t square, x will be L. So here is our m. Okay? Okay, so from here you see gradients equal to 4 pi square over g. This is what we want to get. Okay, so now the question asks if the experiment conduct to moon. So what happened to our gradients? Right? Okay, so here m and g is inversely proportional. So the g at the moon is smaller than Earth, right? So when g decreases, your m will be increases. Okay, so answer increases because the gravitational force of the moon is lower than gravitational force of the Earth. You can using gravitational force or using gravitational acceleration also can. But here if you want to use g, it also doesn't matter because the g is affected by gravitational force now. You want to use gravitational acceleration is correct also. Okay. Okay, so here if let's say we change another question because here so if let's say the question asks you to plot the graph. So the graph with moon gradients will be here, increases, right? You want. Okay. Okay, so before we go for another question, you guys here the prediction asks what predict the changes in example, changes in period oscillation if the pendulum bob changes to 500 gram. Just now we're using 250 gram. So now we change our mass of pendulum bob to heavier one. So what is the impact for period oscillation? Increase. Okay, here we have someone give increase. Any others? Natame, how about your opinion? If the mass of the pendulum bob increases from 250 gram to 500, so what is the changes for T? So the question can be asked like this now. Okay, so again, when you have question, go back to the formula just now. 2 equal to 2 pi square root L over G, right? So is it any parameter involved in mass? No, right? So the answer should be no change. So the period of oscillation will be no change when the mass of the pendulum bob increases or decreases. Okay, understand? Because the formula here, you see no any m, no any mass, is only affected by the length and the gravity. Okay, so please take note for this. So always referring back to this formula. Okay, so now we go for the next question. Okay, so the question number 2 is to determine the gravitational acceleration of Earth, G. Okay, so type of experiment is hypothesis, and then the type of question is guided. Guided practical assignment. Amali Berpandu will be easier actually. Okay, so here again, actually I'm using the same chalice or apparatus. So again, here will be the pendulum bob. Again, here 250 gram, right? So just now I asked if we change to 500 gram, so the mass changes do not affecting the gradients, do not affecting the period oscillation. Please take note for this. Okay, so ruler, stopwatch, red dot stand, we crank, 100 cm threads, protector, cord, new and weight. So all of these will be the same. So you just stick, use 5 minutes to check, and then go to question. Okay, so the question is guided, so the procedure is given. So in this experiment, you are required to determine the gravitational acceleration G using the procedure below. So step 1 is set out the apparatus as shown in diagram 1.1 IOB. Actually, I'm using almost the same concept with the question 1. Just I change the style of the question. So set the length of the pendulum is 60 cm. The mass of pendulum is 250 gram. Okay, then deplace the pendulum to left and let it go as shown in diagram 1.2, like this. So in this question, not mention any angle. Just for one, I advise you to put in, right, because the angle affecting the value of G now. You can leave it like this also, doesn't matter. 10 or 5. Actually, if you search online, the preferring student give 5 angle. Okay? Okay, so deplace the pendulum to left and let it go as shown in diagram 1.2. So record the time taken T for the pendulum to make 10 complete oscillation. So here repeat with 20, okay, sorry, here 0.0, 30.0, 40.0, and 50.0. So actually it's the same result we get. Okay? Okay, so again, here ask you to tabulate the data. Okay, so we revise back what is the importance part. Okay, so again, here, got mistake now because I just copied from the just now one. Okay, so here again, the first must be parameter, simple. Second, correct unit. Third, consistent decimal place for your primary data. All that means that, again, just now we advised already, 11, you must get 11.1, 11.0. One decimal place consistent for all. Okay, then the T, here is a calculation consider secondary reading. So must also give consistent decimal places. Here we give 2. T square, also the same, like just now one. So the tips will be correct, state the quantity physics, unit, primary reading with correct sensitivity and consistency. Then secondary reading also the same, must be consistent decimal places here. 2 must be 2 for all. Okay, so we use the same type of data. Okay, so now you see what I do changes here. I change the graph L against T square. Okay, so what the graph you're going to see? Okay, so just now we using the normal T square against L, right? Because we always mention that NV must be something that changes, then RV must be something that measure, but actually can be reversed. Okay? Okay, so when reverse, we tell you another way actually. Okay, so again, we're using the same data. Okay, so plotting a graph again, we review back. First must be give the quantity physics for each axis. So here must be L against T square already. Your Y will be this, S will be this. Okay, so L change to Y. Reverse. Then T square will be X now. So unit for each axis must be stacked correctly. Same with just now one. Okay, then the uniform skew must be given, including the maximum minimum value. This one I also advised already just now. Okay, then, okay, so this is the maximum and minimum value must be covering in your skew. Okay, will be this. 2.4, we cover already as is at here. 60, we cover already more than that. Okay? Okay, so if I say you have difficulties to plot the graph, you find out the small box represent how many? What's the value represent? Then you just divide Okay, then size of graph, just now we also emphasize actually more than half more than half. The graph plot should be correct for all points. So here again, we should get the baseline, which is straight line, will be this. Okay, so fulfill 2 requirements for baseline will be different point on the above or below the line must be 0 or 1. Cannot be more than 1. So the distance between the point to the line must be less than 0.5. This is what just now we emphasized already. Okay, so this consider baseline. Oh, I think this one should be in your mind already, right? So you remember 16 you need to do so that you get 17. Okay, so I continue. Okay, so C, so I do some changes for the question here. So the relationship between the period of oscillation T and the length of the pendulum is given by this formula. I think this formula will be given to you, just like paper 1 and paper 2. Then from here, they want to test you to understand this formula or not actually. By using your graph in 2B, calculate the gradients. So calculate gradients. First, you have to draw the triangle. Show the biggest one, the last point like this, right angle. Okay, show at your graph. Okay, so you can also give your point here. I use the last point normally. Okay, actually 2.5, right? 2.4, I think 2.40. Okay, 2.40. Okay, so that's why here 2.4. Okay, so here gradients, you use y divide x, y divide x. So you get this value. This one is my value lah. I get 25. But I still put 1.0 But here actually, let's say you have exactly value can give 25. Okay, if not actually you can leave it with minimum 2 decimal places with correct unit. So the unit here, cm, come from here, divide s squared. So we get this unit. So you get 2 marks already. Okay, then based on the equation given and your answer in 2C1, calculate the G in SI unit. This is the objective of this experiment 2, right? Okay, we want to find the G in SI unit. Okay, so again we're using this formula. So you have to change in this form. Why? Because our graph is in L against T square. If I say the question asks to plot T square against L, your G will be different, Your G will be reversed, If you plot T square against L, your M will be 4 pi square on the top, G at the bottom. The common one is this actually. This one I think out of the box reverse They can ask actually. So we don't know what's the graph going to test. They want to test whether you understand this formula or not. Okay, so the common one on textbook will be this, T squared against L, your M will be 4 pi squared over G. Okay, but now I change the question because some of you mentioned that the question come out will be different one. Okay, so I think the different that's for second one will be this Okay, so will be like this. Okay, so from here we know M equal to G over 4 pi squared. The M here is referring to gradients. Normally they're using K, right? Okay, I'm using M already, so I not change but here is gradients. Please take note for this, not mass. It's gradients. Okay, so we get G equal to 5 pi square. M will be the gradients. So M gradients we get already just now, right? With the value of 25.0 cm per second square, right? You have to change to SI unit because the question requests you the G value in SI unit. Okay, right? So I change will become cm to meter divide 100. We get 0.25. It's so easy for changes to SI unit. Then substitute M to here. Pi will be 3.142 So I follow this set of data, I get this 9.87. So from here, the value is greater, right? The value can be smaller, can be greater. So that the question can ask, continue, like Ziqi just now shared to us. The message ask second is what question already? Ask about compare the value of 9.87 with the actual one. The question for second ask about this. Tips from Ziqi, I'm not sure. Okay, so here compare your answer. You see, I also do one set of question almost like this. Compare your answer in 2C2 lah. This is question number 2 lah. Okay, so to actual value is 9.81 meter per second. Explain your answer. Okay, so here I follow the answer I get. So here you should give experiment value G is higher than 9.81. This is the first mark, right? Because the question asks you to compare, you have to give higher. So the question asks you to explain why you get higher. You have to refer back the formula. So here from the formula, G equal to 4 pi square L over T squared. So the G is affected by L and T. So your answer given here. When this one greater, because the length you measure can be too long already. Your time taken too short already, right? You have to give these two explanation why you get higher reading. So here the G is affected by length and period. I think they will be only accepting these two factors. Other factor is not accepted. Okay, so actually if you go through more detail, so the G is actually affected by latitude, right? If like Malaysia, we at equator, the value should be smaller, because if you remember, you learned at chapter 3, the shape will be like this. Equator to center is further, so the G supposed to be smaller. Further, right? Smaller. The pool side will be higher. So if you search internet, they say that if you get 9.78 to 9.83 is common. It's normal because of the impact of the latitude. Okay, I'm not sure whether they will include this or not. However, if you really get 9.83, you still mention greater than 9.81. You still give the factor of length and T. Because the range is not in our syllabus, right? Okay, so if you greater than 9.81, you just discuss length is longer, T you measure is shorter. Okay, so how you write? So here, so if you get greater than 9.81, can be because of the pendulum length is measured longer than actual length. For example, we want to get 20.0, maybe because you measure too long. You measure until the bottom. Suppose you measure until the center of the box actually lah. If I say you go through the detail, you can give whatever suitable answer. So because the pendulum measure longer than actual length you want. Another one you can discuss about the reaction time. It's too short already. You're too fast to stopwatch. As long as you discuss relevant to your comparison. When you greater, you have to discuss about L greater, T shorter. You want. So because the reaction time when stopping the stopwatch was too short, that means that you stop your stopwatch too early. Okay, so this will be the answer. First, you give this. Second, you give one of these. You see only 2 marks, right? First marks must be comparison. Second mark give the reason. Okay, then based on your formula, 2 factors affecting only, which will be L and T. Okay, one. Okay, so just we grab some idea lah, because we don't know what's the question you are going to ask, right? So here, latitude also impact for your value actually, right? So that's why you see the next question. Okay, so before I go for the next question, I give to you. So actually I add on another question already. Okay, so if I get the result greater than 9.81, right? I get 9.87. So impact is because of the length too long and the reaction time too short already. So what you can improve? What is the way you improve your result? Okay, so here. So the first, because the reaction time too short already. So what you can prevent this? So here, time many oscillation. Again, this is actually ask you to give precaution. Precaution to repair your result. So time many oscillation is a method to reduce the reaction time error is a reason. So what means by time many oscillation? That means that just now we use 10 oscillation, right? You can increase to 20, 30. So the more time oscillation you use, the reaction time error will be reduced. Okay? Then, second, you can also use this way. Use 2 persons. One person starts, another person to stop. But however, this is impossible for your experiment, right? Because this is individual. But you can give also, doesn't matter. As long as your method can solve the problem where cause the reaction time too short, they will accept it. Okay? Okay, another reason is related to this one is a time, right? Just now another one is a length. Okay, so the length, so you have to measure the pendulum accurately. So how you do? So again, just now one use 2%. This one is the method. To reduce the reaction time error is the reason. Or we always meet the technique we want to give. Method plus reason for your precaution. Okay, so here, the position of your eyes is perpendicular to skew reading. Right? Because when you measure the length of the pendulum, you go for another side, can be shortened, can be longer, right? Okay, so this answer can be used for both cases. If your G get greater than 9.81, less than 9.1, actually you can use for both. You remember this, right? Okay, so another one is, okay, so measure from pivot. Okay, what is a pivot? Pivot actually is, let's say this is a pendulum, you said. So we have to measure from here, the point where the thread suspend. It's actually from here. Sometimes we measure all the length when we type in. Actually, here is the length where we calculate in already. We straight away measure 100. When we type, we need to do tighten, right? So the length will be decreases already. Okay, so when length decreases, may cause the G become less, actually, right? Okay. Okay, so another one, will be this. Measure from the pivot to the center of the bob. This is a method to ensure accurate pendulum length use or measure also can. Okay, as long as you meet method precision, so your precaution accepted. Okay, so this is the precaution for G greater than 9.81 because I get 9.87 by using the set data from, I'm not sure from which book already. Okay. Okay, so now if you get your result less than 9.81, example you get 9.68, example 9.71, which is less than 9.1, right? So what you are going to answer, same question, compare your result with the actual value. So here you must give less than 9.1, right? Because you get, example, you get 9.81 meter per second square, example. Okay, so here again we need to discuss G affected by L and period 2 only. So you see why your G get less, because the length you measure the length you measure is too short already. Will be like just now one, right? We measure 100. When you type, actually the actual pivot point is actually shorter already, right? Then T should be greater, right? So that make your G less. Always refer to this formula. Okay, so here, because the length measure shorter than the actual, you can give the reason like this. Second, because the swing angle, okay, so here can be because of the swing angle greater than 10 degrees. So as I mentioned to you, when your swing angle is greater than 10, the time taken will be longer actually. Will be longer, so that this will increase the period of oscillation. So that's why the precaution for this experiment want to ensure that students swing or displace less than 10, because this might cause your G become less than 9.81. Normally, result we get less than 9.81 actually. Because why? You see, here normally we measure 100 cm example. When you type, this portion will be shorter already. Student will be not think about this. So it's actually measured from pivot. Second, normally we simply displace only. Sure greater than 10. So that's why you can check with your friend. Most of you should be get less than 9.1 because of the common mistake here. But here you just give based on the formula. Okay, then if like this, the suggestion to improve your result will be different already. So because of reaction time too long, right? So this is due to the swing angle, right? the displaced angle must be, okay, so the second one can use for all lah. Use two person, one start one, another stop sure can reduce the reaction time error. Another one is, I think, later on you see that another answer. Okay, so measure the pendulum length accurately. So again, now you can using the common answer. The position of eyes is perpendicular to skew or reading to avoid parallax error. Oh, okay, so this one should we count two, sorry. Okay, so you can see for the first one is what I mentioned just now. Keep the amplitude of swing less than 10 from the vertical. Actually, this is the precaution for experiment 1 I discussed just now, right? This one must be, this is the method. So to ensure the period of oscillation is independent to amplitude. So this is the reason. When greater than 10 degrees may cause the reaction time too long. Okay, another will be this. Same with just now one. Measure from the pivot to the center of the bob method to ensure accurate pendulum length use. So that means the second one can be used for all. This also can use for all. No matter your result is greater than 9.81 or less than 9.81, you can use. Okay? Okay, anyone? But if let's say they not ask about anything regarding greater or less than, actually all of you can use as long as you give precaution. So the precaution actually for this experiment is swing less than 10 degrees. Okay? Okay, so next. Okay, so predict the changes in the gradients of the graph if this experiment will carry out on the surface of moon. Again, I asked on the surface of moon because we want to do comparison. Okay, so again, you need to do what? You have to rearrange the formula so that make y equal to ms plus c, right? But c is 0 here. So you can see with the graph of L against x, L against t squared, your g over 4 pi squared will be your gradients, different with just now one reverse. Please make sure you understand this. Okay, so your m or gradients here is actually g over 4 pi squared. Okay, so gm and g is right proportional. So when we go for moon g is less, your gradient should be also decreases. All these what we want to discuss here. Sorry, here you see I make mistake already. Bm berkurang. Decreases, Okay, so decreases. Again here, gravitational acceleration, force actually can use If you want to avoid any possible mistake, you use G as gravitational acceleration. Actually, both is the same. Okay, so gravitational acceleration of the Earth is greater than moon. So if the question asks you to estimate the graph, must be lower. All clear? So this is the idea I'll give you Okay, so I think here got another question. Okay, here. This question, predict the changes in the period oscillation T if the experiment was carried out at the North Pole. This is what just now I told you, right? So North Pole and the equator. Equator, Malaysia is at here, right? Malaysia is at equator. So the G should be less. At pole, because the distance is shorter, so the G is greater. Okay, so now predict the period oscillation. So when we change to North Pole experiment, from your school we change to North Pole to conduct experiment. So what happened to your T? Okay, so straight away you can see here, right? The T and the G is inversely proportional, right? So when go for pole, who is greater? Your T should be shorter, right? Always refer one and only formula. So period oscillation is slightly decreases as gravitational pull, or just how we say what? As the gravitational acceleration, right? Actually, pull is not wrong also. Gravitational acceleration at North Pole is greater than Malaysia, which is located at equator. Okay, so before we left this experiment, okay, so now we review highlight of the graph. You see, for the experiment 1, actually we discussed about T square against L. This is a common used in the textbook. Okay, T square against L. And then another one is I try to think another way. So can be asked you L against T square also lah. So the graph you see both is actually almost the same. So what's the difference here? You see. So the formula T square equal to 4 pi square G over L. Actually we arrange from this formula lah. Okay, I get this lah. Here, remember this is our Y. This is M, this is X lah. So our M will be 4 pi square over G. Then G and M inversely proportional. So that means that when you go for moon, G is lower, your M should be greater. Understand? Then here, if G decreases, your M will be increases using moon. Sure, the question can ask at North Pole will be vice versa, right? So here will be the moon gradients where the G is lower lower than Malaysia here, right? In Earth this one you compare Earth Okay, so another one, L against T square. Actually, I also using this formula we arrange. Now our Y is different already. So our graph will be like this. Okay, so your gradients will be G over 4 pi square. Then if like this, M and G is directly proportional. When G increases, G decreases, the M will be decreases. M referring to gradients, I mean here. So your graph will be like this. Okay, one. Okay, so if I say the question change to North Pole, so for this will be here because the North Pole have crater G, right? When crater G, M will be decreases. Here will be reversal. When at North Pole, G will be increases, then your M will be increases if this is North Pole. However, the difference between North Pole and equator is very small difference. Okay? Okay, so that's all for this discussion, for these two questions.